So hello everyone. Today I will discuss the coordination chemistry. It is my first slide in which one renowned scientist known as Barnes, they give some major points regarding the coordination chemistry. So they perform the systematic study to understand the bonding and coordination compounds. Okay, coordination compound have been seen in natural substance like that chlorophyll, hemoglobin, and vitamin B12 like that. And they said that organic bonding theory and simple ideas of organic charges were not sufficient to understand the coordination chemistry. So they said that two types of bonding. Okay, first is the primary, and second and another is the secondary. Primary is known as positive charge of the metal ion is balanced by the negative ion in the compound. Then the second one is secondary, molecules are and ligands are attached directly to the metal ion. Okay, so primary valency, suppose that the complex is FeCN ka whole 6. So in this primary valency is this one. Okay, K4 means positively metal containing uh, positively metals, and the secondary valency is this one in which ligand is attached to the central metal ions. The next one is very important slide in this this side. The transition metal acts as a Lewis base, because if you see the coordination compound, then like that coordination compound is FeCN ka whole 6, uh, FeCN ka whole 6 3 minus. So in this is the transition metal iron. Okay, iron, nickel, cobalt, these are all the transition metals because they belongs from D block elements. So they act as a Lewis acid because if you see the nature of the ligands, then ligands donate the electrons. Okay, so ligands donate the electrons, so they act as a Lewis base, and central metal ion means transition metal ion act as a Lewis acid. Okay, so it is the Lewis acid, it is the Lewis base. When combined together they form the complex ion. Okay, so Lewis acid means metals, and they are always positively charged, and the Lewis base are always as negative charge, and when combined together they form the complex ion. The second one is the Lewis acid, it is nickel plus 2, and when combined to the Lewis base means ammonia, they form the complex ion. Okay, and you can see nickel NH3 whole 6 2 plus formed. So if you see this complex containing the central metal ion bonded to one or more molecules are anions, and this is called the ligands, or you can say Lewis base. While if you see the Lewis acid, it is the metal, it is the metal, and it is the Lewis base, it is also known as ligands, and they are the molecule or ion covalently bonded to the metal in the complex. So Lewis acid is the metal, Lewis acid is the metal, and it is present in the center of the coordination. Okay, so all of you are aware from the two terms, one is the Lewis acid and one is the Lewis base. Lewis acid, this is the metal which act as a Lewis acid, and they present in the center of the coordination sphere, while Lewis base which act as a ligand, and it is the molecules which are covalently bonded to the metal in the complex molecule. Okay, so simply if you see this FeCN ka whole 6, then I will draw this molecule. This is the metal which acts as a Lewis acid, and ligand which are present in this like that FeCN donate the electron to the central metal ion, so that's why it is known as ligands are Lewis base. This, okay, so it is the structure, and it is the ligands, it is the central metal which act as a Lewis acid. Okay, so Lewis acid means central metal having the some vacant orbital in his ligands donate the electron and negative charge to the orbitals, you can say. So next slide we will discuss here to so in this complex with the net charge is known as complex ion. Complex have distinct properties. Okay, so complex ion formed by the Lewis acid and Lewis base. Okay, and the complex with the net charge is known as complex ion. Okay, complex ion, this is they are all the complex ion, and complex having distinct properties. Okay, so next slide reveals the coordination compound. So compound that contain one or more complex, example you can see this one. Okay, so this is the coordination compound. So this is the complex NH3 ka whole 6. This is the complex ion. Okay, when chloride ionized. Okay, so if 3 chloride ion ionized, that this is the complex ion because they contain the +3 charge. Okay, so looks like that. Another compound, it is the coordination. So coordination compound containing the coordination sphere. You can see this one. This is the FeCN ka whole 6 3 plus. So this is the coordination sphere. This bracket is known as coordination sphere, and number of ligands is known as coordination number, or you can say number of donor atom bonded to the central metal atom is known as coordination number. And coordination sphere, this bracket containing the metals and the ligands, and metal and the ligands. And larger ligands are those substance negative charge to the metal that known as coordination number. So it is simply determined by the ligands. So coordination number determined by the ligands, and it is the number of ligands present in the coordination sphere. Okay, so coordination in coordination chemistry, complex charge is equal to the sum of charge on the metal and the ligands. Okay, so complex charge means -3. The oxidation state of iron is +3, and Cn is Cn containing the -1, so it is the -6. So -6, it will 6 -3. If you calculate this one, so oxidation number of iron you can find out. So next slide, coordination chemistry. So this is the law, this is the idea by which you can calculate the oxidation number of iron. Next is the coordination chemistry. In this, it is revealed the neutral charge of the coordination compound is equal to sum of charge on the metal, ligand, and counterbalancing ion. Okay, so some of the ligands are neutral, means their oxidation state is 0. Okay, like that ammonia, water. Okay, CO, like that, they are all the neutral ligands. So in this ammonia, the oxidation state of ammonia is 0. So cobalt Cl2 means 2Cl minus, it is equal to the +2. So cobalt cutting the oxidation number of +2. So in this, ligands has been explained. So ligands classified according to number of donor atoms, and the ligand is 1, then it is known as monodentate. If sites of ligand is 2, means donor site is 2, then it is known as bidentate. If donor site is 3, therefore then it is known as tetradentate. If donor site is 6, then it is known as hexadentate. If donor site is more than 2, then it is known as polydentate. So they are uh, if more than number of donor atom is 2, means more than 2 bidentate to polydentate, they form the chelating agents, and the chelating agents are responsible for the stability of the molecules. So ligands are various types. There's a monodentate. So these are the ligands which act monodentate are water Cn minus, ammonia NO2 SCN minus, OH minus, halides COO2 minus. Example complex, you can see this one. Bidentate oxalate ion, the chemical formula of oxalate ion C2O4. This is the formed by oxalic acid, you can say. And if you replace 2 hydrogen, then 2 negative charge appear, and it is known as oxalate ion. Ethylene diamine is a simple molecules, and this is very important because this is ethylene. These 2 carbon containing the ethylene, they act as a diamine. Orthophenanthrolene, it is represented by OFPHEN. Examples in which this type of ligands appear, they are like that, looks like that. Okay, so don't fear from that, they are the ligands and bidentate. So oxalate ion I have discussed. This is the CO minus, this is the CO minus, this is the ethylene diamine in which 2 amine are present, orthophenanthrolene. So they act as the bidentate ligands. Another oxalate ion, this is the oxalate in which this is the 2 oxygen, this is the 2 carbon. Okay, attached from the 2 uh, this is the carbon, this is the oxygen, having the 2 lone pair, and this oxygen negative charge binded from the central metal ion. Ethylene diamine, this is the ethylene diamine, this is the 2 carbon, this is the 2 nitrogen attached from the central metal ion. Next one, this is the ligands and this from the octahedral geometries in which central metal attached from the 6 ligands, and this is the ethylene diamine. So in this the ethylene diamine uh, attached from the central metal ion. Next one, if you see the hexadentate, so here they can donate the 6 lone pair of electron to the central metal. It is ethylene diamine tetraacetate EDTA. Okay, so ethylene means these are 2 carbon, diamines mean NH2, so ethylene diamine, and tetraacetate means there will be, if you replace 2 hydrogen from acetate CH2 CO minus. Okay, looks like CH2 CO minus, and this is the CH2 CO minus, CH2 CO minus, then they form the ethylene diamine tetraacetate. Okay, so the examples of complexes looks like that. So EDTA, further ADTA structure you can I have also discussed earlier, or you can say CS2 CS2, this is the N, this is the N, this is CS2 COO minus, this is the N, this is the CS2 CO minus, this is the CS2 CO minus, this is the CS2 CO minus. This is the structure of ADTA, looks like that. Okay, and it combines from the metal. This is the ethylene diamine tetraacetate. So common geometry of complexes is 2, means it from the linear molecule in, okay. This is the best example, AgNH3 का whole twice plus. This is the coordinates number 4, they form the tetrahedral and square planar, and tetrahedral is the most common, and the square planar characteristic complex with 8 electrons. So next one is the some complexes from the tetrahedral like the zinc, iron, and some from the square planar. This is the geometry. This is the coordinates number 6 from the octahedral geometries. This is the equatorial, and this is the square planar. This is the some complex compound forming the octahedral geometries. The cation IPAC name, it is a simple which reveals the first cation is named before the anion, and naming of the complex ligand are named first, alphabetical order you will mention, and the metal ion is named last. Oxidation state given the Roman numerical following the param, used no spaces in the complex ion. The name of the ionic ligands end with suffix O, I suffix change to O, I suffix change to I2, 8 suffix change to A2. So some ligands and their specific name during the, if you do the IPAC nomenclature, bromide, this is known as bromo, chloride, this is known as chloro, cyanide, this is known as cyano, this hydroxo, this is the oxido, oxo, fluorido, fluoro. Okay, carbonato, oxalato, sulfato, thiocyanato, thiosulfato, and sulfato. Neutral ligands are referred to by the usual name of the molecules like ethylene diamines. Exceptions are H2O, NH3, and CO, which is known as neutral ligands. Nomenclature for more than 2 or 3 ligands. For 2 ligands, this is known as di. 2 ligands, tri. 3 3 tetra, 4 3 tetra, 4 penta, 5 hexa, like that. Okay, contain use alternative prefix bis, tis, tetrakis, pentakis, hexakis, like that. So if the complex is anion, the name ends with 8, like that. So this is the scandium means scandate, titanium means titanate, vanadium means vanadate, chromium means chromate, magnesium magnetite, ferrate, cobaltate, nickelate, cuprate, zincate. So it is the IPAC nomenclature. You can see. Next one is the isomerism. Isomers compound that has the same composition but a different arrangement of atoms is known as isomers. Major types is structural stereo. Structural isomers that have the different bonds. Coordination sphere, different in elegant bonded the metal is the complex as opposed to being outside the coordination sphere. So coordination sphere isomers, these are the two coordination. So this in this you can say ligands have been interchanged from each other, and two complex ions are formed in this one type of isomerism. So this is the isomers. Okay, you can see this one. Okay, linkage isomers can easily be identified the presence of ambidentate ligands. So ONO and NO2 both are the ambidentate ligands. Linkage isomerism also forms in the compound having the NO2 groups in which two sides ONO and NO2. Next one, linkage isomers. This is the NCS and SCN. Both are same molecule, but sites of donating the electron is different. Okay, so these are the linkage isomers. Okay, so these I have discussed in short some main points regarding the coordination compounds, and it is the major concept you can see which appear in the coordination chemistry. So learn this one and some read more from the questions given in the unsolved papers like that. So thank you for all for hearing this lecture. Thank you very much for that.